this is the Emory breast imaging dataset, or EMBED. You'll hear it referred to many times. The key points here are it's about 115,000 patients. It's about 364,000 exams. So an exam is a full screening study or a full diagnostic study. So in a screening study, you have your 4 standard views, or maybe 6 if they had repeats. Your diagnostic might have 3 views, it might have 8 views, it might have 10 views. So that 360,000 exams adds up to about 3.4 million images. We also have about 40,000 regions of interest of abnormalities on those images, which Beatrice will talk about a little bit tomorrow. So if an abnormality was detected on the image, which would be a BI-RADS, so screening study with an abnormality is a BI-RADS. On screening? 0, good. So screening can only be 0, 1, or 2, right? So a portion of those studies that are abnormal on screening will have an actual ROI or lesion location that you can take advantage of during the datathon if you want. Okay. We then have a MagView database, which I'll show what that is, but that is all of the descriptors for the image and the pathology. So when we talked about the description of masses, calcifications, what types they were, right? The pathology, if that lesion was biopsied, the pathology is in there, the date of that biopsy is in there, and the BI-RAD score is in there. So screening exam, you can get what BI-RAD score was assigned for a diagnostic. You get the BI-RAD score 1 through 6, right? And then the density is in there, right? So is the density A, B, C, or D, right? Then we have pathology reports, which we won't really be using, but because the pathology information is already structured inside of MagView. And then we have some clinical data, which is like the demographics, social history, treatment history, risk factors, etc. Okay, so this is the full synopsis. It is relatively evenly split between black and white patients. There is significantly fewer Asian patients, and then very little of the remainder of demographics. It's all female. There are male patients that get mammograms, but we won't really go into that. There's a small proportion of Hispanic patients. There's about 3,700 total cancers in the data set. Okay. This is just a general workflow of what's done to the image. So every image, so we didn't talk about this too much. Let's talk about image type tomorrow. I don't want anybody to get too confused, so we'll come back to this tomorrow. But there are multiple ways you can acquire a mammogram. So you can acquire it in 2D, you can acquire it in 3D, you can take that 3D and make it a 2D reconstruction. So there are various image types for any given view. So if you have a CC view of the right breast, you could have a 2D view of it. You can also have a 3D view of it, and you can also have a C view, which is a 2D reconstruction. Okay. But what we did do is, if you are going to work with diagnostic mammograms, one of the biggest problems is there's these big fat artifacts on the image. And who gets diagnostic mammograms? What patient gets a diagnostic mammogram? BI-RAD 0 on screening or symptoms, right. So if you have a diagnostic mammogram, is your likelihood of having cancer higher or lower than a screening patient? Like way higher, like 20 times higher, right? Or more. I didn't do the math, but it's significantly higher. So if you put the diagnostic mammograms into your model and 50% of diagnostic studies have cancer and 1% of screening studies have cancer, what is the model going to learn? Paddles. The model will learn paddles equal cancer, right? So we process the data by removing the paddles and just leaving the tissue inside the paddles, right? So we have that specialist. So in the data set, it is identified which mammogram is a special view, so you can throw those out. Somewhere laying around, I think we have the masks of the tissue actually extracted, but that might be too much for the datathon. But at least if you're going to use diagnostic mammograms, you know which diagnostic mammograms have paddles and which ones don't, so that you can treat them separately, right? You could take all the diagnostic mammograms with paddles, and if all of them have paddles, you could train a model for that and say cancer, no cancer, if all of them have paddles. Question? It would, unless you cropped the image and took patches from it, right? So there's all these strategies. But yeah, if you put in this full image into the model, then it would learn it just as easily as the image with the paddle, right? But then if you know where the tissue is, you could take a section of that tissue in the middle and then make sure there's no blank space around it. Okay. The other thing I talked about ROIs earlier, it was a huge pain in the butt to get these, but it's worth it because we have 40,000 ROIs. So this is a screening study. The radiologist saw something. They drew a big circle on it that got hard-coded into the image instead of saved as a DICOM object, which was very bad. So we had to train a model to find the circle on the image and then map the coordinates of that circle from the screen save. This is a screen save image anytime something is burned on into the actual mammogram. So these are the ROIs that Beatrice will talk about. So we have the coordinates of these patches that contain the abnormality that the radiologist detected on the screening study. Okay, so you could take advantage of those and then you can track that out in MagView and see this one became a cancer, this one was a BI-RADS 4, this one was biopsied but it was benign, etc. Okay, so let's let me think. I think we will do this tomorrow. Let me give you a really brief intro. Everything, so there's two tables you got to worry about, okay? Everybody say MagView. MagView, good. Everybody say metadata. Okay, two tables, okay? Don't get them mixed up. MagView and metadata. Okay, I'll make it very simple. MagView contains everything that the radiologist said about the exam. Okay, so MagView contains one row per finding. So if it's a screening study and the radiologist saw something in the left breast, there will be a row in MagView that contains everything that the radiologist said about that exam, whether it was a calcification, whether it was a mass, what was the BI-RADS score, if it was biopsied, what was the pathology, what's the breast density. It's all the clinical information about the exam, okay? What table is that? MagView, good. Okay, good. So if you are trying to figure out something that the radiologist would have described that would be in the report, or if you're trying to figure out the demographics of the patient or any lesion descriptors, you look in MagView. Okay, we'll go through these columns tomorrow, but this is what it looks like. Pretty simple, right? Each row is one finding. We have a patient ID, an accession ID, the date, whether it was a screening or diagnostic mammogram. Most findings, 90% of screeners are BI-RADS 1 and 2, correct? They're negative. That means they have no findings, no mass, no calcification. The assessment is N negative, BI-RADS 1, right? That's how you read this row. This diagnostic, well, that's a diagnostic. Here's a screening, right? Screening bilateral mammogram, no findings, nothing was seen. The BI-RADS is BI-RADS 1, negative. And that's it. There's nothing else. 900 out of every 1,000 screening exams will look just like that. Okay? But this one, for example, is a bilateral screening exam. There was a finding on the left side. It was mass shape F. So there's a key, there's a table to look it up. The shape of that mass was F. The assessment was A for additional evaluation, BI-RADS 0. So if I was to track this patient out and look at all their subsequent exams, I could see what happened. In this case, they didn't get a biopsy. That means on diagnostic, they probably got a BI-RADS 1 or 2. They went back into the screening pool. But this one here, this one has a diagnostic exam. They have an abnormality in the right breast. It's described by these mass features, okay? It was given an S for suspicious, which is a BI-RADS 4. This will all be written out. And then it went on to biopsy. So the diagnostic exam was on December 4th. The biopsy was actually the same day, which is really rare, and it was found to be invasive cancer. So we'll talk about path severity tomorrow. This is a ranking system with 0 being invasive cancer, 1 being non-invasive, and so on. So if you're trying to find cancer versus no cancer, you look at path severity. So this is the heart of MagView, right? MagView is one row per finding. So if there was a screening bilateral and there was a finding in the left breast and the right breast, you'd have one row for left breast, and then you'd have another row for the same accession on the same date with finding number 2, and it would say right breast here, and they would describe what they said it saw on the right breast. Okay? Conceptually, does this make sense? Okay, so the important thing to know in MagView, the way to link this to images is the accession number. Accession number is the exam ID. That's what we use in radiology for all of our exams. Everything has an accession number. All the images for that exam are linked to that accession number. So if you want to take a row from MagView and go find the images for it, you'll go to table number 2, which is metadata. Look for that accession number. All the images for that accession will be in the metadata table. Okay? If you want some light reading tonight, go to GitHub and you can see the, the description of all of the findings. Okay, no extra credit. You guys should do something fun. So, DICOM metadata. Okay, so the metadata file is actually pretty simple. So, DICOM file is a container, right, of the image plus all the metadata files. So, in this metadata file is all of those DICOM tags that not all of them, not all 1,000 of them, but about 200 of the DICOM metadata tags that were in the files. So every row in the DICOM metadata table is one file, okay? So if you have a screening exam with a right CC, a right MLO, a left CC, and a left MLO, you'll have row 1 is the right CC. It'll be accession number 1, right CC, and the file path. Accession number 2, right MLO and the file path. Accession number 1 still. Accession 1, right CC. Accession 1, left CC. Accession 1, right MLO. Accession 1, left MLO. So every image in that exam gets one entry in the metadata file. Does that make sense? Okay. So screening study, a negative screening exam in MagView will have one entry because there's nothing to describe. It'll just say it's negative. You go to the metadata table, and there'll typically be 4 files in the metadata table, one that represents each view. And along with those files will be the study description, series description, the view, the manufacturer, and then the stuff that we added, like the location of the ROI, the image type, which we'll talk about tomorrow, 2D, 3D, or C view, and the laterality, which we had to do some gymnastics to abstract. So let's take, okay, perfect. So this is it. There's this slide and the next slide, and then we're done. Okay, so you guys just hang in there. This is a random sample of the metadata table. So I just literally randomly sampled out of 3.4 million rows. I sampled 10 rows. So each one of these you can see is a different accession, right? This is an accession ending in 322. This is in 037. So this row is the right CC of this accession, which is a diagnostic bilateral exam. It's the 2D right CC view, and there was no ROI. And the thing I didn't show here is that at the end of this will be the file path. It'll actually tell you the path of the image, the path of the DICOM file, okay? This row is the left CC 2D image of this accession. This one, let's say here, is the right ML view of the 3D image, the tomosynthesis, right? So these are in the data set. We won't be using them for the datathon, but if you want to use just 2D images, we'll just change this final image type to 2D, and you'll filter it down that way, okay? So let's say I have this exam ending in 880, a screening bilateral exam. I want to see all the files, all the images for that. Then I will take my metadata table, and I will filter it by that accession. So here are all of the files for this accession number. You can see here for 2D, I've got my right CC, right MLO, left CC, and left MLO for 2D. I've got my 4 C view images, again, which we'll talk about, and I've got my 4 3D images. So this now represents, if you find a finding in MagView, you grab this accession number, come to the metadata table, you punch in that accession number, and you get all the images for that accession. Okay, so what's the clinical findings table? MagView. What's this one? Metadata. And how do you link between MagView and metadata? Accession number. Good. If you remember that much, you will have a huge head start. We'll cover the rest of this tomorrow. All right. Thank you.